All right, if we start with the understanding of how to take some kind of radical and convert it over to a rational exponent, I could take this first example here and rewrite that 12th root of 8 as 8 to the 1/12th power. And I could rewrite that 4th root of 8 as 8 to the 1/4th power. Now, a little trick I'm going to use to help me simplify this a little bit further. I could, as it stands, take these like bases, multiply them together, and add these exponents. But it'd be simpler if I took these 8s and I thought about a prime number raised to a power that gives me 8 back. So a prime number like 2 raised to the 3rd power, right? That would give me 8 back. So if I take this 8 idea out, which I understand is raised to the 1/12th, I replace it with some prime base raised to a power that gives me 8, so 2 to the 3rd. 2 to the 3rd would be raised to the 1/12th power. And likewise, over here, this 8, if I replace that as 2 to the 3rd, that would be raised to the 1/4th power. Now, what does that mean? That means I've got power to power. So if I got power to power, I multiply. This 3 gets multiplied to 1/12th, I get 3/12ths, right? And if I reduce 3/12ths, I get 1/4. Likewise over here, if I take that power to power, 3 times 1/4, get 3/4, you got 2 to the 3/4. Where now, arguably, I'm in the same position as where I was up here. I've got like bases where I could multiply through by adding the exponents, right? But it's just easier now that I've created that prime base. It's easier too because I got common denominators. If I multiply here and keep my base would be 2. Add your powers, you've got 1/4 plus 3/4, so obviously that's 4/4 or just 1. We're trying to evaluate here. Looks like we're done, right? Looks like 2 is our answer. Okay, if we try the second one, on the second one, what I might do first, since I see the negative exponent outside here, I might go ahead and create a reciprocal idea where I take this 1/81st that's inside the parentheses, flip that over, and bring it down here. Make this equal to 81, right? That's the reciprocal of 1 over 81. It'd be 81 to the positive 3/4 power now. So let's try this little prime base trick again. Take 81 and start thinking of prime numbers, 2, 3, 5, etc. Any of those values raised to a certain power that give you 81, you could insert here. You guys have any ideas? What if I told you 3 was a prime base we could work with here? You know what the power would be on that 3 that gives me 81? 4. There we go. 3 to the 4th. 3 to the 4th power is 81. So I replace 81 with 3 to the 4th power. I understand that I'm raising that to the 3/4 power overall because originally that's what 81 was raised to. Now if I follow my power to power idea here where I multiply those out, 4 times 3/4, well, basically these 4s are canceling out, right? You got 3 to the 3rd left. 3 to the 3rd is pretty simple to calculate, right? That's 27. All right, so for this initial cube root problem here, why don't we start by rewriting all the radicals in a rational exponent form. So underneath this cube root, I've got a 4th root of 5, so that's 5 to the 1/4. That's being multiplied to a 4th root of 25, so that's 25 to the 1/4. Since all of that's under the cube root, overall, I'll rewrite all of that raised to a power of 1/3 to represent that cube root. Okay. Inside the parentheses, I'm multiplying a couple of exponential expressions. The bases are not the same. However, this 25, I could rewrite that as 5 to the second. If I make this 5 to the second power, that overall is being raised to the 1/4 power. Of course, that's being multiplied to the 5 to the 1/4, all of which is being raised to 1/3. So all I did there to change the problem was I changed the 25 to 5 to the second. Now, when I take this 2 times this 1/4 to do the power to power trick, that's going to give me 2/4, right? So let me make that note. I've multiplied here, that's 2/4. These are the same bases. So if I'm multiplying with the same bases, base stays the same, stays as 5, but add your exponents, 1/4 and 2/4, I get 3/4 back. So inside simplified to 5 to the 3/4, overall, we're raising this to a power 1/3. Or now if I do a little power to power multiplication, these 3's would cancel out, right? And I'd be left with 5 to the 1/4 power, where I'm simplifying, so I could leave it in that form, but I did start in radical form, so it's probably better practice to convert back. Instead of saying 5 to the 1/4, convert back and say the 4th root of 5. I'd say that's a better answer. All right, so next one here. Starts similar to how I started the last one. Here you've got a cube root of a 4th root of 27. So let's take that 4th root that's underneath that cube root. Take that 27, raise it to the 1/4 power. Then understand that we've got a cube root applied to all that. So overall, we'll raise this to a 1/3 power. We're multiplying. Over here, we got the square root of a square root. So I'm going to take 27, starting with the square root containing that 27 underneath the other square root. We'll take this 27, whoops, we'll raise that to a 1/2. Overall, again, because of the outer square root, overall we'll raise this to a power 1/2. All right, let's see where that gets us. Well, we got some power to power stuff going on here. We've got 27 raised to the 1/4 times 1/3 would be 1/12. Over here we've got 27 raised to the 1/2 times 1/2, so that's 1/4. All right, I got like bases here I'm multiplying, so I can go ahead and compute through if I want to. Or we could go ahead and create those prime bases. It really doesn't matter. If I'm being consistent here, I'll create some prime bases. 27 would be 3 to the 3rd. So you've got 3 to the 3rd raised to the 1/12 times. Over here I've got 3 to the 3rd raised to the 1/4. So what ends up happening here? If I multiply these powers, 3 times 1/12, I get 3/12, which reduces to 1/4. Over here I got 3 times 1/4, so that's 3/4. Got your like bases, multiply, we keep the bases 3. If you add your exponents, you got 1/4 plus 3/4, which is just 1. So answer becomes 3. All right, so introducing the variables now, we've got the square root of x times the cube root of x squared. Similar strategy to before. Let's get rid of the radical form, write it in a rational exponent form. So square root of x would be x to the 1/2. The cube root of x squared. that would be x, well, since it's squared, it would be 2/3. That'd be my power. So I'm not dealing with actual numbers here. I got variables, so I can't use the little prime trick like we did before. Here I do have like bases, so I could multiply by adding my exponents. Adding my exponents, finding a common denominator, let's see, I'd have x to the 3/6, right, times x to the 4/6. So that would give me x, adding those powers, to the 7/6. Which, if I convert that to the radical form, right, because that's how I started, I want to go back to how I started. Denominator gives me the index number, so it'd be the 6th root. And then numerator, I can just slap on that x that's underneath that root. Now there is more we can actually do with this. There's more we can do with this because I'm dealing with a 6th root. And if I broke down x to the 7th into factors, I know x to the 7th is x to the 6th times x to the 1st, right? So the 6th root of x to the 6th would be x to the 1st, meaning I would have an x, because that represents the 6th root of this factor, x to the 6th. But then there's this extra x I couldn't do anything with. So that would stay under the root. X times the square root of x would be the answer. Right, so last one. First thing I would do with this one is clean it up a little bit because I do have this negative exponent here. This would all equal the 4th root. It's going to turn into a quotient because of that negative exponent. You're going to have this 16x to the 11th that remains in the numerator. But we got to bump that y to the negative 4th down and make this y to the 4th down here. All right, if we think about what this means, when we apply a radical overall to a quotient, it means we're taking the 4th root of the top over the 4th root of the bottom. So if I wanted to rewrite that, I could. Now, if you look at what results, now let's start with the easier piece here. That 4th root of y to the 4th in the denominator. That's just going to be y, right? Okay. Now we refocus the attention to the top. You've got the 4th root of a product, so I'm taking the 4th root of 16. I'm taking the 4th root of x to the 11th. Start with that 16. Can you take the 4th root of 16? Be 2, sure. So that's nice. As far as the x to the 11th is concerned, again, I could do something similar to what I just did over here, but if you take this 11, divide by 4. 11 divided by 4, well, that's going to be 2, right, with a remainder of 3. So what does that mean? That means an x is going to pop out. 4 went into 11 2 times, so the power on that x is going to be 2. Now, you got to be careful here how you're writing these out, too, because if you got a power here and you got your 4th root there, got to make sure it's clear. The 4th root is applied to the radical. So 4 went into 11 2 times. We get x to the 2nd out here. You've got the 4th root of a remainder, right? Now, you're going to have an x under here. You know what the power is going to be on that x? It's going to be 3 because that was the remainder from taking 11 and dividing by 4. So 11 divided by 4 goes in 2 times, remainder of 3. That's how we break that down.